This video will cover the second page of notes on the topic of radical equations. Let's start with example number 2. Our job is to solve the equation square root of 2x plus 3 minus the square root of x plus 1, and that's equal to 1. So we're still going to do the same steps that we did in page 1. So we're still going to do the steps that we did in page 1. The first thing that we needed to do was to isolate our radical. And now notice in our problem, we actually have two radicals. So which one should we isolate? So if you notice, when we came back up here, we actually have the word ugly in here. So you want to isolate the ugliest radical, whichever one that may be. I know both of them may be equally ugly, then just pick one. So here, I decided to say that the 2x plus 3 is probably uglier. And so I'm going to make sure I keep this, and I'm going to add the square root of x plus 1 to both sides. And that's how you see that I have the square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. So first thing we needed to do was to isolate the radical, but since we had two of them, we actually had to isolate one of them, and we called that one the ugly radical. So you get to pick. For step 2, the next thing we need to do is to get rid of the radical. So we're going to put one set of parentheses on the left, one set of parentheses on the right, and then we're going to put a power. So here's our one set of parentheses on the left, one set of parentheses on the right. Since we had square root, we're going to square both sides. Notice this should remind you of FOIL. So the square and the square root will cancel out, and that's how I get 2x plus 3. Over here, I have to actually think of it as FOIL, so I'm going to have to multiply these guys. So I'm going to multiply 1 times 1. That's how I got this one. I'm going to multiply the square root times the square root. Remember, we talked about those two canceling each other out. That would be this guy right here. And the inside, it's going to be one of the square roots, and the outside one also gives me another square root. So I'm going to get 2 of those square roots. So now we can see them right here. So this is me doing my FLIO as opposed to FOIL. So I have my 1 and I have my square root squared, so we know that that's going to cancel out. And then over here I have 2 times the square root of x plus 1. So I'm going to simplify that. That's this part right here. Notice this is what we get. And if we come back to the previous page, we saw that in our notes on how to solve, we had to ask this question: did we get rid of the square root? If the answer is you still have a square root, then you have to go back and start all over again. But if there's no more square root, then you get to go to the next step. So when we come back here, we see that we have a square root right here. So we get to start all over again. So we need to get this guy by itself. So that means I need to get rid of the 2, so I'm going to subtract 2 to both sides. I need to get rid of the x, so I can subtract x to both sides. So here I am. I end up with 2x minus x. That's how I end up with x. 3 minus 2. That's how I end up with the 1. So these are gone. And now I have is equal to 2 times the square root of x plus 1. So I need to get rid of this 2, so I'm going to divide both sides by 2. And then we can see that now I need to square both sides. So since I couldn't really divide this, I'm just going to put one set of parentheses on this side, one set of parentheses on this side, which the 2's canceled out. Since this is square root, I need to square both sides. So that's what you see right here. That I am squaring both the sides. So if we have a fraction, remember that the square will actually go to both the numerator and the denominator. So you can see that here. So I did FOIL at the top. That's how I got x squared plus 2x plus 1. I squared the bottom. That's how I got a 4. And that's equal to, well, the square and the square root cancel, and that's how I ended up with x plus 1. I have a fraction. You guys don't like fractions, so we're going to multiply both sides by the LCD. In our case, the LCD is 4. So I multiplied this side by 4 and this side by 4. Over here, remember that's still like 4 over 1. That will cancel those two out, and I just end up with x squared plus 2x plus 1. That's what we see here. And over here, I end up with 4 times x plus 1. Using the distributive property, that's how I end up with 4x plus 4. All right, so we got rid of the radical, so that's where we are in terms of our step. Since we don't have any radicals, we're going to go to step 3. To remind you, step 3 is to solve for x, and if you have quadratic, try factoring. We come back to our equation, we see that we do have quadratic, so in order for us to factor, we're going to have to set it equal to 0. So since I have x squared here and it's positive, I'm going to subtract 4x to both sides. And that's how you see how I got my negative 2x. I'm going to subtract 4 to both sides, and that's how we got my minus 3. And on this side, everything went away, so that's how we got it equal to 0. So I have a quadratic equation. I'm going to factor, set each of those factors equal to 0. So we found these two answers. The next thing we need to do is to check our work. In step 4, our job is to check for the solutions in the original equation. So over here, you can see that I checked for x is equal to negative 1. And over here, you see I have checked to see what happens when x is equal to 3. And we actually found that both of them work. So our solution set will include both of our answers. And that concludes this video.